Hello students, welcome back to our channel Diksha Karnataka. So mock test 5 has been released on March 29th. So I hope all of you have attempted it. So in this video, we'll be discussing the first 30 questions of chemistry solution. So this will be the part 1 where we'll be discussing from question number 1 to question number 30. Right? So let us see the first question. Okay, and the PDF of this question paper is available in the WhatsApp channel. The link of the WhatsApp channel will be there in the description section. You can go there and download it if you haven't yet. So let us see the first question. Of the ions Zn2 plus, CO3 plus and Cr3 plus, some statements are given regarding the color. So first of all, what is the condition for being colorless? That is, there should be fully filled orbitals. If the elements are fully filled, then there will be no color, okay, because of lack of DD transition. So we can see this one, Zn2 plus. Zn2 plus configuration is 3D10, okay, which is fully filled. Next, if you see cobalt 3 plus, what is the electronic configuration of cobalt? 4s2 and 3d7, right? So 3 plus means it is 3d6, okay, it will have some unpaired electrons. And now coming to chromium 3 plus, chromium electronic configuration is 3d5 and 4s2, right? So 3 plus means we'll get 3d4. So we can see there is unpaired electron in cobalt 3 plus and chromium 3 plus. So Zn2 plus will be colorless and the other two will be colored compounds. So only Zn2 plus is colorless and CO3 plus and Cr3 plus are colored. So correct answer for this question is option A. So the thing you should know is what is the condition for being colored and colorless compounds. Okay, next question. Mercury is liquid at room temperature. This is due to. Okay. So first of all, what is the condition? Again, we have to understand these are all questions from D and F block. So if intermolecular forces, okay, is very strong, then the element can exist in solid. If it is weaker, then it will be in the liquid state, right? So first of all, that is the reason. So high viscosity has nothing to do with this one. Weak metallic bonding and weak van der Waals forces. Okay, so in D block elements, we generally found metallic bonding due to the presence of unpaired electrons. So because this unpaired electrons are less, metallic bonding is weak. So that is why the compound is liquid. Okay, so the correct answer for this question is option B. You should also remember mercury is the only metal which exists in the liquid state at room temperature. Okay, next. Which of the following are D block elements but not regarded as transition elements? Okay, so here also what is the condition for transition elements? They should not have fully filled orbitals. Should not have fully filled orbitals either in the native state, okay, or in common oxidation state. Okay, so if they are having fully filled d orbitals, then the answer then they will be called as they will not be called as transition elements. So you can see copper, silver and gold, they are having 3d10. For copper it is 4s1. In the common oxidation state for copper it is 3d9, right? The copper oxidation state is Cu plus and Cu2 plus. So in their common oxidation state it is having unpaired electron, or you can say like partially filled d orbitals. So this cannot be the answer. The correct answer for this is zinc, cadmium and mercury. Zinc electronic configuration is 3d10 4s2 in the ground state, and in the common oxidation state it is 3d10, which is Zn2 plus. So you can see in the native state and in the common oxidation state it is fully filled. So that is why correct answer for this question is option D. Next, the correct order of ionic radii given. So from lanthanum to lutetium, okay, the ionic radii keeps on decreasing. The reason for this is lanthanide contraction. So the smallest size will definitely be of lutetium and the largest one will be lanthanum. Even if you don't know about this, from the options you can see the correct answer is option C. Okay, lutetium will be smallest and lanthanum size will be bigger. Next question. The hypothetical complex of is given. Okay, we have to find out the formula. First of all, we'll check triamine, right? There should be 3 amine. So all the options are having 3 amine. Next, it is diaqua. So 2 aqua groups are there. Here there is 3 and here there is 1. So we can eliminate these 2 options. Next we have chlorido. So you can see this option is having chloride, this also is having chloride. Now cobalt is 3, then chloride is present. When this chloride is present, this is an auxiliary ion, or you can say counter ion. Means it should be present outside the coordination sphere. But here we can see no chlorine outside. So the correct answer for this question is option A. Next, which of the following species represents the example of dsp2 hybridization? So for first of all, for dsp2 and sp3, okay, the coordination number should be 4. This one you have to keep, coordination number should be 4. So we can eliminate this answer and this answer because here the coordination number is 6. Now after that, dsp2 is absorbed whenever we have strong field ligands. Okay, if you compare Cn and NH3, Cn is a stronger field ligand, right? So the correct answer for this question is option B. Next, which compound does not show paramagnetism? So for paramagnetism, we should have unpaired electrons, right? So if you can see here, what is the oxidation state of copper here? 2 plus. Copper 2 plus is 3d9, which is having unpaired electrons. Then if you see Ag, here oxidation state of Ag is +1. So the configuration is 4d10. Okay, so it's not 3D element, it is 4d10. So the configuration will get 4d10, completely filled, no unpaired electrons. So that will not show paramagnetism. So what is paramagnetism? When there is unpaired electrons are present. And the opposite of one, diamagnetism, is where no unpaired electrons are present. Okay, these are basic definitions. Okay, next. Which of the following solutions will exhibit the highest boiling point? Okay, so now this question has come from your solutions chapter. Very high weightage topic, solutions. So we have already discussed many questions. For highest boiling point, what should be the factor? Say delta TB is equal to I into M into KB, right? KB is a constant. So what I can say, delta TB is proportional to IM. We can calculate IM for all the options and then we can check. So for this one, it is I is equal to 3, 2 sodium ion and 1 sulfate ion. So 3 into 0.01 is 0.03. Now here there is 2 ions, 0.01, so we'll get 0.02. Here urea, for urea the I factor is 1, so it will become 0.015. For glucose also it is 0.015, right? So the correct answer for this question is option A. IM will be maximum, then delta TB will also be maximum. But the opposite happens in freezing point, okay? Next question. Osmotic pressure absorbed when benzoic acid is dissolved in benzene is less than the expected value. This is because. So whenever there is the value decreases, it is due to association, and the value increases due to dissociation. So the correct answer for this question is organic solute, there is no relation, has higher molar mass, also no relation. Benzoic acid gets associated in benzene. Correct answer is option C. Okay, next. Standard reduction potential of the elements A, B and C are given. So we can write down A value is 0.34, B value is minus 3.05 and C value is plus 2.86. The order of their oxidizing power. So see here, oxidizing power is directly proportional to reduction potential. Higher the reduction potential, higher will be the oxidizing power, right? So now if we see whose reduction potential is maximum, C. So the oxidizing power will also be maximum for C. So this one we can eliminate, this one we can eliminate. We have two options left. Next one is for A. So C, A and then B. Correct answer will be option C. Next. For hydrogen oxygen fuel cell 1 atom 1 atm 298 Kelvin, reaction is given, delta G is given, E naught we have to calculate. So direct formula based question from electrochemistry. Delta G is equal to minus NF E naught of the cell. So delta G given is minus 240 into 10 to the power of 3. For hydrogen fuel cell, N is equal to minus 2 and E naught of the cell. Okay. So now you can just check here, the options are very close, right? All the options are given very close. So you have to do little like detailed calculation for this one. So if you calculate this value, E naught of the cell, we will be getting around 1.24. Okay. So correct answer for this question is option A. Okay. Next. RCO or H2O in presence of acid giving you acidic medium gives you acid and alcohol. So this is the catalysis of esters. Which type of reaction is this? We know acidic medium, hydrolysis of esters are pseudo first order reaction. So the correct answer for this question is option C. Direct example based question from kinetics. Next. Okay, half-life, again kinetics question. So solutions and kinetics are very high weightage topics. So please revise these formulas again and again. Half-life period of a reaction is found to be the inversely proportional to the cube of the initial concentration. So for this you should know the general formula. T half is inversely proportional to 1 by a to the power of n minus 1, right? So according to the question, what is there? T half is proportional to 1 by a to the power of cube, a3, right? So I can equate n minus 1 is equal to 3. So n will be equal to 4, right? So it is a fourth order reaction. Correct answer for this question is option A. Okay, next. The incorrect relation for a first order reaction is, okay, this relation is correct. We have another relation also. You have to remember these two so that you can solve the questions easily. Then this is integrated rate law. This is a zeroth order law. This equation is for zeroth law, right? And this is also correct. So the correct answer for this question is option C. Next. Okay. For the reaction 2N2O5, 4NO2O2 rate and rate constants are given, the concentration of N2O5 at that time will be. Okay. So we know rate is equal to K into concentration of N2O5, right? Rate given is 1.02 into 10 to the power of minus 4. K value is 3.4 into 10 to the power of minus 5 into concentration. Now if I want to calculate only concentration, then if you divide 1.02 into 10 to the power of minus 4 divided by 3.4 into 10 to the power of minus 5. So if you check, this calculation will get 10.2 by 3.4, which is nothing but equal to 3, right? So the correct answer for this question is 3 moles per liter. Okay, next. Okay, again kinetics question. Reaction is first order in A, okay, and second order in B. So first we can write the rate law. What will be rate? K into first order with respect to A and second order with respect to B, right? Now how is the rate affected when the concentration of A and B are doubled? So next time we have to take R dash K 2 times of A and 2 times of B, right? It is doubled. Now if you see, we'll get 8 times of Ka and B 2. So I'll get R dash is equal to 8 times of initial rate, right? So correct answer for this question is option B. Direct and easy question. Okay, another again kinetics question. A reaction which is first order with respect to reactant A has a rate constant of this one. If we start with A equal to this much, when would A reach the value of this? Okay, so this is again integrated rate law of first order. So integrated rate law for zeroth order and first order, more numericals are asked. So this question, how we can solve? Let us see. First write down the formula. We know integrated rate law, A naught by A. Okay, the question is asked in what time? So I can write 2.303 by K value given is 0.6 log of A naught value. We have started with 0.5 and after that it is 0.05, right? So this will become log 10 and we know log 10 value is 1. Here we can write it as 2.3 by 0.6. So that is around something around near to 4 the answer will come, right? Because 6 4s is 24. So somewhere around 3 or 3 point, yeah, so 3.84, right? The correct answer for this question is option D. Let us see the next question. So we have from electrochemistry, copper electrode potential is asked here. So we can write, see, copper 2 plus, what is the reaction? Cu2 plus 2 electrons will give you Cu. Now the reaction, the standard electron potential is 0.34. So I told you standard electrode potential is when the concentration is 1 molar. Now if the concentration is changed to 0.01 molar, then what will be the electrode potential of copper? So here we can replace like this, E of copper 2 plus copper is equal to E naught of copper 2 plus copper minus 0.06 by 2. It is 0.059. For calculations, we can take this value log of 1 by copper 2 plus concentration is 10 to the power of minus 2. So now we have to calculate this value, right? And then E naught value is 0.34 minus 0.06 divided by 2 into this will come 2. So we can cancel, so we'll get around 0.28. So the correct answer for this question is option B. Okay, next. Molar conductivities of at infinite dilution for different concentrations HCl, CH3CONA, NaCl are given. The molar conductivity of CH3COH at some other dilution is also given. Calculate the degree of ionization of acetic acid. So first of all, what is the formula for degree of ionization? Alpha is equal to lambda m by lambda naught m. Lambda m is the molar conductivity at any concentration. Lambda naught m is the molar conductivity at infinite dilution or the limiting molar conductivity. Limiting molar conductivity can be calculated using Kohlrausch's law for weak acids. So if we want to calculate for CH3COH, the lambda m value, it can be done in this way. You can take lambda m of CH3COONA. See, we need this part, right? This part is present in which of the three values? CH3CONA. And then we need H value. H value is present from HCl. So lambda naught of HCl. Now in this, when you add, we are getting this NaCl extra, right? That we have to remove. So minus lambda naught of NaCl. So if we solve this value, we'll get I'll write the values here. HCl value is 384. CH3COOH value is 78 and NaCl value is 102. So if we solve this for this one, we will get 78 is for CH3CONA. Okay. So 78 plus 384 and then minus 102. So if we solve this, we'll get 360, right? Now we can substitute that value here. 108 by 360, right? So if you cancel this one, we'll get 0.3. Okay, so the correct answer for this question is option C. Next, H2S is a toxic gas with rotten egg smell, is used for qualitative analysis. Mole fraction of H2S in water at STP is given to you. Henry's law constant. So direct, again we came to solutions chapter. Easy one, direct Henry's law formula. P of the gas is equal to KH into mole fraction of the gas. Now then we have to calculate KH, that is mole fraction of the gas divided P of the gas divided by mole fraction of the gas. Standard pressure means 1 atm. So you can see the units are is also in 1 atm. So 1 atm by the mole fraction, that is 0.004. So we will get 250, right? So the correct answer for this question is option B. Okay, next, a binary. Okay, again the question is from solutions. The topic is ideal and non-ideal solutions, positive and negative deviations. A liquid solution is prepared by mixing N-heftane and ethanol. Which of the following statement is correct regarding the behavior of the solution? So first of all, they will form a non-ideal solution, right? So option A we can eliminate, okay? And then this is also non-ideal. Okay, now we'll check about the deviation. So ethanol molecules, if you check, they have hydrogen bonding in them, right? Ethanol molecules, if you take the solution of ethanol molecules, we will have hydrogen bonding between them. So now when we are mixing it with heptane, what will happen? The bonding between the ethanol molecule will be disturbed, right? So the interactions have become weaker. So if it is a weaker interaction, then it is a positive deviation. So which option will be having positive deviation? Yes. So correct answer for this question is option B. Okay, next. This is theory based question. So please learn the examples for positive deviation and negative deviation and maximum boiling azeotrope and minimum boiling azeotrope. So these examples are asked, so please prepare those examples. Now let us see the next question. So this question is again from solutions chapter. 45 gram of ethylene glycol is mixed with 600 gram of water. The freezing point depression is. So we know delta TF is equal to KF into M. So KF for water you can remember it is 1.86. M value is your given mass, that is 45 gram, sorry, given mass of the solute is 45 gram, and then we have the molar mass of this one is 60 into 1000 by 600. Okay, so you can calculate here. So if you calculate this one, the correct answer will be getting is 2.25. Okay, so the answer is option number B. This question requires little calculation. You have to give some time for this question. Next, the decreasing order of osmotic pressure of 10 gram of glucose. So glucose is taken as P1, right? And then sucrose, glucose. Okay, so in that we have urea. Urea is P2, and we have last is your sucrose where it is P3. Okay, osmotic pressure formula, if you remember, number of moles, that is C pressure is equal to C into R into T. C can be written as number of moles by volume, which can be written as given mass by molar mass, okay, into 1000 by volume, R into T. So I can say that osmotic pressure is inversely proportional to molar mass, right? So if we see this, for glucose the molar mass is 180, urea 60 and sucrose is 342. These values you could have remembered, many questions are asked from this molecules. So you see the osmotic pressure will be is inversely proportional. So where the molar mass is more, the osmotic pressure will be less. So sucrose is having the highest molar mass, so the osmotic pressure will be least. So P3 will be least. So we can eliminate these two options. Now out of P, so P2 will be highest because it is the least molar mass. So the P2 will be highest. So correct answer is option C. Easy little application based question. Okay, next. So this is from some basic concepts of chemistry. First topic, on analysis of a compound was found to contain 254 gram of iodine and 64 gram of oxygen. The molecular formula of the compound is very easy. First find the number of moles. Number of moles of iodine will be what? Given mass by molar mass. So that is equal to 2. So number of moles of iodine and number of moles of oxygen. 64 by 16, that is 4. So we will get I2O4. If the empirical formula would have been asked, then the answer would have been IO. But the question is asked about molecular formula. The correct answer for this question is option B. Easy one. Okay, next. Nitrogen laser produces, so we have come for structure of atom, right? Produces a wavelength of this much nanometer. If the number of photons emitted is this one, the power of the laser is. Okay, so we have know this formula. E is equal to NHC by lambda. So let us substitute all the values. How many photons are ejected? 5.6 into 10 to the power of 24. H value is 6.3 into 10 to the power of minus 34. And then C value is 3 into 10 to the power of 8. Divided by, here you have to be careful, the unit of wavelength should be nanometer. It should be converted to meter. So I'll get 337.1 into 10 to the power of minus 9 meter, right? So if we solve this, the correct answer for this question will be option B. Again, this calculation is lengthy. You have to give some time for this question, okay? Next, which one of the following arrangements represent the correct order of electron gain enthalpy? Very, very important question from the exceptions in the periodic table. So now you see, if we go along a period, what happens to electron gain enthalpy? Electron gain enthalpy increases along a period, right? Now what are the elements we are having? Here we have oxygen, sulfur and fluorine and chlorine. So definitely fluorine and chlorine will have higher electron gain enthalpy than oxygen and sulfur. So either the first one should be fluorine or chlorine. So from that we can eliminate these two options, right? Now coming to whether it is chlorine or fluorine, we know because of small size of fluorine and due to inter-electronic repulsions, chlorine has higher electron gain enthalpy than fluorine, right? This you have to remember, it is not an exception. We generally, chlorines will have more electron gain enthalpy as compared to fluorine. So the correct answer for this question will be option B. Similarly, sulfur will have more electron gain enthalpy than oxygen because of the small size of oxygen and interelectronic repulsions, right? So correct answer is option B. Okay, next question. Formal charge CO3 2 minus. Okay, we have to calculate the formal charge on carbon, double bonded oxygen and the single bonded oxygen. So let us write the formula for formal charge. Formal charge formula is valence electron minus lone pair of electrons minus half of bonded electrons, right? Okay, now if you compare carbon, for carbon, how many valence electrons are there for carbon? 4, right? Minus lone pair, there is no lone pair here, 0, minus half of bonding electrons. So we have 1, 2, 3, 4, 5, 6 and 7, 8, right? Now if you this one will get 4 minus 4, 0, right? So we can eliminate these options. These two we can check. Now let us calculate on double bonded oxygen. Formal charge on double bonded oxygen. Double bonded oxygen. So first is the total number of valence electron for oxygen is 6, right? Next, minus how many? Okay, how many we have non-bonding electrons? So here only 2 are there. Sorry, 2 lone pairs are there. Okay, so 6 minus will get 4 minus half of bonding electrons. So bonding electrons is again 4. So if you see, we'll get 2 minus 2, that is equal to 0. So we will get 0, 0. This option we can also eliminate. This one again, is it clear? Total valence electron is 6. Number of unpaired electrons are 4 or non-bonding electrons are 4 and number of bonding electrons are 4. So half of 4. So 6 minus 4 minus half of 4 will get 0. Now coming to this one. Formal charge on single bonded oxygen. Okay. So first the number of valence electrons are 6 minus, here we have 6 electrons. So number of non-bonding electrons are 6 minus half of bonding electrons. Right, we'll get minus 1. So the correct answer for this question is option C. Okay. Which of the following pairs are isoelectronic? What is the meaning of isoelectronic? Same number of electrons. You can see sodium is having 11 electrons, plus means 10 electrons, neon is also 10 electrons. So the correct answer is option B. This is very easy and direct question. Okay, now coming to thermodynamics. The system is provided with 50 joule of heat and work done on the system, very very important, work done on the system is 10 joules. Then the change in internal energy during the process is. So we know this formula for first order, first law of thermodynamics, delta U is equal to Q plus W, right? Then what will be delta Q is the heat provided, that is 50 joules, and W is the work done on the system. So if work is done on the system, the sign convention will be positive. Similarly, heat is provided to the system, so Q will be positive. So that means this one will be 10 joules. So we will get 60 joules, right? So the correct answer for this question is option B. Okay, this is again a question from thermodynamics, important one. The values of delta H and delta S for different reactions are given. On the basis of these values, predict which one of these will be spontaneous at all temperature. So for the reaction to be spontaneous, the condition should be delta G should be negative. And what is the equation for delta G? Delta G is equal to delta H minus T into delta S. So here we have to find out what should be the condition that it can be negative in all values of temperature. So that is possible only when delta H is negative and delta S is positive. So if this one is negative and this one is positive, we will get the equation like this, right? Delta H minus T delta S. So when two negative numbers are added, the sum will also be a negative number and delta G will be negative for all the temperatures taken. So that is why we can see here delta G is positive, sorry, delta H is positive, so we can eliminate that. Then delta S is negative here, so we can eliminate this option. Delta H is positive, this one is also incorrect. Here delta H is negative and delta S is positive, right? So the correct answer for this question is reaction 4. So if you have found this video useful, please like the video, share with all your friends and subscribe the channel.